Hello, everyone. Good morning, good afternoon, good evening. A very warm welcome to our webinar, How to Stream IoT MQTT Messages into the Azure Event Hub service. I'm Jayashree Hegde, the moderator for this webinar. It is a pleasure to have you all. I'm happy to introduce you all to our speaker for today, Matthias Hofschen. Matthias is senior consultant at HiveMQ Professional Services. He has a vast experience in streaming architectures. He supports HiveMQ customers to implement their IoT and MQTT use cases and architectures, and also helps them in solving their challenges and building mission critical solutions. So accompanied by Matthias is Gaurav Suman, Director of Product Marketing at HiveMQ, who will be helping with the Q&A. Before we get started, I would like to share a couple of housekeeping pointers. We are recording this session and all participants will be on mute. We'll be sharing both the recording and the presentation in a follow-up email. And if you have any questions during the presentation, feel free to type them in the Q&A pod or the Q&A box in the control panel. We will answer them during the Q&A session at the end of the webinar. And please refrain from using the chat pod for Q&A, but feel free to interact with everyone. And during the Q&A, we will be running a poll. So I request you all to participate and provide feedback. Now, without further ado, I will hand it over to Matthias. Welcome, everyone. Over to you, Matthias.
Yep. So, just a second. Thank you, Jayashree, for the introduction, and welcome everybody to this webinar on how to stream IoT messages into the Azure Event Hub service. Jayashree has already introduced me. If you want to reach out, you can use my email address or LinkedIn. And with that, I want to take a minute and set the context for what we're talking about today. Here in Germany, in the late 1800s, the adoption of a unified stamp system brought new reliability and usability to the postal system. On the right here, you can see the old post office in Berlin-Neukölln, a very beautiful building. Much earlier, we had Inca runners transporting messages encoded in knotted strings along the Inca roadways. These were called quipus. Unfortunately, the protocol for these strings is not known anymore, and the payload can no longer be read. These systems address a diverse messaging need through standard compliance and interoperability. And today, here we are with billions of devices that transfer messages across the globe, and most of these devices speak MQTT. The agenda for today is that for about 35-40 minutes, I will talk about the challenges to IoT architectures. I will talk about HiveMQ installation on Azure Kubernetes cluster and the connection to an Azure Event Hubs queue. Then come some considerations that I find important for IoT architectures and scenarios like this, a summary, and then we go over into the Q&A section, and hopefully we'll have about 15 to 20 minutes for that session. So the IoT architecture challenges. So there is a diverse set of requirements and that are posed towards IoT architectures, and these depend largely on customer-specific use cases and the scale that a solution needs to provide. So we have use case specific requirements such as message delivery guarantees, topic tree designs that have to be implemented. There are payload specifications. There are new standards that define topic trees and payloads such as Sparkplug. There's latency requirements that use cases have. Infrastructures are diverse as well. There is on-premise installations, AWS Cloud, Azure, Google, and other providers. There's the edge, which can take on many different forms such as wavelength zones from AWS or any type of other edge as to your definition. There's a diverse set of backend systems that IoT architectures have to work together with. These architectures are not a greenfield approach to things. Mostly there is an enterprise that has business units. These business units have requirements towards data collection or data message communication, and these have to be taken into account. Microservices, data lakes, stream processors, databases, time series databases, machine learning pipelines, management dashboards that summarize information to the board. The devices and clients are also diverse. There are scenarios where some devices speak MQTT 3.1.1 and other devices speak MQTT 5. These need to be interoperable with each other. There is processing capabilities that clients have, such as the processing power, the CPU power that a device has at its availability. There's load. Load is diverse. It goes from hundreds to thousands to 100,000s to millions of devices that need to be connected. And there is a factor of geographic distribution, be it factories around the world, moving vehicles, the public transport sector, or things like water and energy infrastructures, home-based devices like set-top boxes that have to be connected. So we need solutions that provide certain characteristics. These characteristics are a payload agnostic solution. MQTT at its core is a binary protocol, and it can take any formats such as text-based formats like JSON, JSON, XML, or encoded formats like protobuf, or follow specifications, for example, again, the Sparkplug specification. Of course, we need solutions that provide scalability, reliability, and availability. So we need elastic scaling according to load. We need to have reliability features such as replication and fault tolerance built into the solution. We need interoperability for hybrid device scenarios. Again, the scenario that as you bring your use case online, maybe you start out with a pure MQTT 3.1.1 device scenario. And then as new machines are installed on the factory floor, for example, MQTT 5 is rolled out, and you will never have a moment in time that you can just switch all machines over to the new MQTT protocol. There will always be a mixed scenario needed to be supported. The deployment needs to be agnostic as well. Deployments must be possible on bare metal, on VMs, via containers, using Kubernetes, to support on factory floor installations, edge installations, cloud installations, and so on. And then we need the flexible integrations with existing applications and systems, because the data is going to be needed by many business units, and hence we need flexible integrations. So if I look at MQTT use cases, which is why we're really here. There is needs, there's a use case, there's an enterprise that has a use case that needs to be implemented. These use cases come from various different verticals. There is the automotive industry with automotive use cases, the connected car. There is industry IoT use cases that center around manufacturing. Logistics use cases, be it trucking or any other type of logistical need. Telecommunication use cases, leveraging the 5G networks and building things around that. And then there is, in general, a lot of use cases that require a reliable IoT messaging middleware. And with that, I just wanted to quickly show you on our website, on our homepage, there is under product, market, customer stories. We have a bunch of customer stories, and it's really enlightening to see what kind of a use case is implemented with using the MQTT protocol. Take a look at that. Maybe there is use cases that you find giving you inspiration for ideas. For example, Aware is tracking indoor air quality, which is the IoT messaging middleware use case. Quite interesting. So yeah, if you take a look at this, you find some inspiration for your use cases. So if we take a look into the section of industry, Internet of Things, we have factories that are geographically distributed. And it's particularly interesting to see how information technology gets merged with operational technology. And in the area of Industry 4.0 provides new use cases around machine-to-machine communication, big data collection and then analysis, and machine learning. And in these use cases often center around things like the production visibility and monitoring, automated data collection, increased machine utilization, predictive maintenance, facilities management, and optimized logistics. So now we go to look at a very simplified architecture overview. And I just want to talk a little bit about the terms that are used here. We have an MQTT broker, and we have a message queue at the center of this architecture. The MQTT broker uses the MQTT protocol. So MQTT is a client-server publish, subscribe messaging transport protocol. It's simply a standard. It's defined by a technical committee in the OASIS Foundation, and that is basically what MQTT is. An MQTT broker is part of a solution, and it acts as an intermediary between clients, devices, sensors, or even backend applications, and so on and so forth. The message queue is a system where you send messages into. It's saving these messages for a defined period of time, and data consumers can consume these messages on the other side, so to speak. So these are two different things, the message queue and the message broker. So now we want to go into the details of how to install HiveMQ and connect it to Azure Event Hubs. So with that, if we put some names onto the architecture, you can see that the MQTT broker is now becoming the HiveMQ broker, and the message queue is becoming the Azure Event Hubs. And this is what I will show now. If you take a look at what would be required to get this up and running, there's various different possibilities to achieve the setup. I'm just seeing in the Q&A there's a mention where LB is load balancer. Yeah, so LB load balancer. So the setup is quite complex. You can do this, or actually it's not that complex. It's just a lot of user interfaces to click through to install the Kubernetes service or to install Event Hubs, or you can use the command line client from Azure, the AZ command line client, do it that way. And there's, of course, a lot of ways to automate that and make sure that you have like a CI pipeline that rolls out the whole solution in a repeatable fashion in an automated way. So you don't have to take many notes during this webinar. there's blog posts that you can find the technical details on how to do this. Let me quickly show you. So if you go to the HiveMQ homepage, there is a section blog. And here, right now, it's still up top. You know, in 2 weeks, it's not going to be on top anymore. This is a detailed description of how to set up Azure Event Hubs, how to configure HiveMQ and the Kafka extension that we're using to do the connection. And I'm explaining that in a bit. You can do this. You don't need licenses. You just go ahead and try it out. And also, the second blog post that I would recommend, if you want to use the Kubernetes service, if you search here for AKS, you find a blog post on how to deploy a HiveMQ cluster on the Azure Kubernetes service as a stateful set. With you can also do it without a stateful set, but this blog post is with a stateful set. And then, of course, the link to the HiveMQ documentation is always recommendable. You should find all the information that is necessary for you to configure and run HiveMQ. If you find something missing, drop us a line so we can do something about that. Okay, so we'll come to the first part of the setup. We want to install HiveMQ on the Azure Kubernetes service. So we need an AKS cluster. I have already installed the cluster because I don't want to show clicking through the user interface to create the cluster. It's not a big deal. It's like maybe 10 clicks or something like that. Of course, you need an Azure subscription to do that, but otherwise, it's not a big deal. Once there is a Kubernetes cluster, then we want to take the publicly available Helm charts that HiveMQ provides that use the HiveMQ operator and then install a HiveMQ cluster on Kubernetes. So let's go ahead and do that part. So I'll show you the command line. And first of all, we'll just take a quick look at the nodes. So my local kubectl context has the Azure Kubernetes service already as the current context. And I can see I have two nodes, two Kubernetes nodes. These are, I think, B4 MS or something like that. These are not powerful machines. They're plenty fine for this demo. If you want to go towards production, you want to probably use like a compute optimized instance, something that starts with F. But for now, we have these two nodes. And there should be nothing running here. So I will just go ahead and install via Helm. So this command will install via the Helm charts, the HiveMQ Helm charts, the HiveMQ operator. At the same time, I'm submitting my request for a HiveMQ cluster, which the operator then picks up and tries to instantiate by talking to Kubernetes and giving him the various different objects that it would need for the HiveMQ cluster to run. So you can see that we have HiveMQ test deployed, so via Helm, and I can see it's in the process. If I get the parts that are running right now, I see that the HiveMQ operator is already running, but the pods are not running yet. So we'll wait for that to happen. It should take about like 45 seconds or a minute or so. And in the meantime, we'll take a look at the next section. So this is about Azure Event Hubs. And I just want to clarify a couple of like the terminology that we are using here. So Azure Event Hubs, I find the naming a little hard to get used to because the plural Azure Event Hubs and the Event Hubs namespace would be the equivalent to a Kafka cluster. The singular event hub is a queue, is equivalent to a Kafka topic. And then both systems have partitions to partition the data further. And you can see on the right side how that would look like. I have a HiveMQ running with the HiveMQ Enterprise extension for Kafka. It connects to the Event Hub queue. In this case, it's called HMQ inbound for this example here. And that queue has partitions which are actually then responsible for storing the message that we're sending there. Okay. So in the meantime, I can see that the HiveMQ nodes are running. It took 45 seconds to get there. So if I take a look, I have the operator running and I have two HiveMQ nodes running. So in most of my slides, I have 3 nodes, but I just using 2 nodes as an example. So that's looking good. I want to take a look at the control center. So HiveMQ comes with a user interface that's called the HiveMQ Control Center. In order to access that, I need to find out the address to which I need to direct my call. So I look at the deployed services. By the way, if you see me typing KC, that's just because I'm lazy and I don't want to type a kubectl all the time. KC is just a local alias for kubectl. So I want to look at the service, and you can see that there's a bunch of services available. CC stands for the control center. That's what I'm interested in right now. So I'm going to copy this IP address here. Go back, open a browser window. Paste that up there. Go to port 8080. And can log in. So for you, for everybody that knows HiveMQ already, this is not the standard logging for the control center. I did change it. Okay, so you can see we're looking at the HiveMQ control center. Up in the top right corner, you can see the number of cluster nodes that participate for this. We can see the Kafka dashboard. It checks successfully. That means from HiveMQ's perspective, we have a successful connection to Azure Event Hubs. And that's really all that there is to see here. Okay, so good. So we're connected. Now comes the next part. And what I want to show you here is, okay, why is this actually working? And it has to do with a very nice feature that Azure Event Hubs provides. It provides a Kafka API compatible layer. So it has a Kafka API for the consumer and the producer API that's specified by Kafka. Starting with version 1.0. So I can use the HiveMQ Enterprise extension for Kafka to connect to Event Hub. There's one thing I have to observe here. Event Hub, Azure Event Hub comes in different pricing tiers. The basic pricing tier does not have the Kafka API available, but the standard tier does. So if you try this out, you have to use the standard tier in order to have a successful connection. So what this graphic here shows is just simply the message flow. We have on the left side IoT devices that send messages into the HiveMQ cluster via the MQTT protocol. The HiveMQ cluster has the extension the Kafka extension installed, which makes a so-called mapping to a topic or an event hub on the Azure Event Hub side, or if we would have a Kafka, to the Kafka topic. Then we have a reverse mapping on the Kafka extension that picks up messages again and forwards them and posts them to or publishes them to a topic. And if I have a subscriber, if I have a device that subscribes to that topic, that device receives the message. So it's your classic ping pong example where messages go forth and back. Maybe a couple of words to the extension. What is an extension? Earlier in IoT Challenges, I was talking about we need flexibility. For HiveMQ, there is an extension SDK. It's a developer kit. It's available and offers a plug-in possibility into the brokers. So for IoT use cases that require special adaptations that might be possible to do with a custom extension or with an extension that is available on our marketplace. We have both open source extensions and commercial extensions available. So there's quite a lot of possibilities here. Again, find the details on the HiveMQ website. That'll definitely help to get that done. So let's take a look at this ping pong example. So on the MQTT Broker, I am having a topic that gets a publish. The topic is data PLC1. The message is some silly string up and running. This is being forwarded via the Kafka extension to Azure Event Hub. And because of the configuration in that extension, I'm particularly forwarding it to the Event Hub queue called HiveMQ-inbound. The message is stored on Event Hub and is just generally available there. At the same time, to get the Pong side of things, I'm having another mapping in the Kafka extension that reads from that very same Event Hub queue, HiveMQ-inbound, and reads messages that show up there, and then publishes them without further configuration to the MQTT topic HiveMQ-inbound. So if I then have a client that connects to the MQTT Broker and subscribes to that topic HiveMQ-inbound, you should be able to receive that message. So quite simple ping pong. There's a lot of configurations possible here. For example, I can direct it to any MQTT topic on the return trip that I want to. I can even do this individually on a per message basis. So I don't mean to say that this is the only way we can do things. This is just the most simplest example for the explanation. Okay, so I guess then we'll just do that. I have two windows here. On the left side, I'll have the publisher, and on the right side, I'll have the subscriber. So as a client, I of course need an MQTT client to connect to my HiveMQ cluster on the Azure Kubernetes service. And we have an open source MQTT client available, a command line client, which I'm going to use now. It's the MQTT CLI. It's actually, if you download the HiveMQ platform, there's a tools directory inside of that download, which is containing the MQTT CLI. So I simply start the CLI, I simply start the MQTT CLI in shell mode. So now I'm inside of this client, let's put it this way, for the publisher. Now I'm going to do the same for the subscriber. Okay, now I want to connect this client to the broker. So the connection needs, of course, a host to connect to. And from the service, I get an IP address for the MQTT service. This is the service that runs on the standard MQTT port 1883. So I'll just simply copy this address here and use it. Then I want to give this client a unique a unique client ID. And this is password protected, so I need a user and a password. That's the simplest way to do authentication using the open source file RBAC extension. For production use cases, I would really recommend to take a look at the enterprise security extension that can be used to implement OAuth authentication flows. LDAP can be incorporated, database-based authentication and authorization, and a bunch of other things. So as a user, I have a lane. And the lane has a password. And the publisher is connected to the broker now, has a standing TCP connection, and can subscribe and publish messages with that. I do the same with the subscriber. So I'll connect again with the IP address. We use client ID subscriber. The user in this case is Kramer, and the password is Kramer123. Okay, so both publisher and subscriber are connected. So in order for the subscriber to actually receive a message, it needs to subscribe to a topic. And I've said that the topic that I'm expecting to get the return message from Azure Event Hub is HMQ-inbound. So let's subscribe to that topic. -S is just simply in interactive mode, so we can see the messages arriving. On the publisher side, I can now go ahead and publish messages to the ping messages, essentially. So the messages that go to the message broker and are then forwarded to Azure Event Hub. And I'm allowed to publish to data, to anything under the topic level data. So I would pub to the topic data, and let's do it like on the slides. Some PLC device, it was ID 1. I send a message, and again, this is just a silly message that I'm up and running. So you can see that the subscriber receives the message pretty instantaneous, but keep in mind that I'm sitting here somewhere north of Munich, connected to the Azure Kubernetes service, the HiveMQ cluster that's running on the Kubernetes service. That HiveMQ cluster has the Kafka extension that is connected to Azure Event Hubs. I think I'm using the Frankfurt region, and then from there it goes back to the HiveMQ cluster, and the second client picks it up. Okay, so this seems fine. With that, we'll go back to the presentation. So as a final look at the setup, okay, so this slide is actually slightly incorrect. I don't have 3 nodes, I just have 2 nodes, but not a big deal. The Event Hubs queue sits in the middle, and then I have all these backend applications that can access the data. So let's take a look at some of the considerations that I would be using message queues, the message broker, and so on and so forth in my IoT architectures. So the one thing is that message queues are helpful. I mean, they are not helpful in every use case, but in many, many use cases, they are helpful to decouple enterprise data consumers for more flexibility. What do I mean with that? When the message queue decouples data consumers that come from different business units, then I make this data widely available within the enterprise. I also have the benefit of a scalable, reliable MQTT message broker, because HiveMQ is 100% implementation of the MQTT standard with all the optional features. So I can use that 100% compatibility for my MQTT use cases, connect the message queue to the HiveMQ broker, and make all the messages and the MQTT data available to the Azure data environment, be it the analytics service, capturing it to blob storage, hooking up different machine learning pipelines into the streaming processors, and so on and so forth. So for Azure customers, so for people that have already, for enterprises that have already an Azure subscription and do a lot of computing for their backend services on Azure, this is a great way of integrating systems. So a couple of advantages of the message queue. The data consumers in the backend are often not latency sensitive. Storage to blob storage, for example, or into a Hadoop data lake is not latency sensitive. And that means that sending the messages to a message queue decouples the broker, the active MQTT communication, from the usage of the data in the backend. That means that data is only consumed once from the broker, is stored in the message queue, and from there, all the backend applications, stream processes, and so on and so forth can access the data and use the data. So data is consumed once, which also means that the load on the broker system, on the production MQTT broker system, is predefined. I'm setting the queue, I'm sending the messages to the message queue, and that is an always stable load on this production system. If then I can add new consumers to the message queue. So the message queue can be read by as many consumers that are necessary. Okay, if you use too many consumers, you will have to go to a higher pricing tier on Azure, but that's what it is. You can hook up different data consumers. You can even go and do exploratory data analysis. The data is available for you, for your use cases, for your business units, and you can allow a new business unit or a new exploratory data use case to access the data without having any fear of endangering your production environment. It's decoupled. And as a suggestion, maybe this would be also a good place to put data governance into place, because if messages all flow through one message queue, then that becomes one location to implement data governance. So then if we look at the MQTT broker, and we look at the advantages of being 100% compatible to the MQTT protocol with all the optional features, I keep saying with all the optional features is very important. We have the full range of all the features available for your use case. MQTT was developed quite some time ago, primarily to enable and empower MQTT use cases and real customer use cases. When the new specification 2018 for MQTT5 was established, that was a direct answer to knowledge from the field, what customers needed and wanted. So it is not a good idea to use brokers that are not fully MQTT compliant. You're cutting down on the availability of features for your use cases. We need to be payload agnostic. We need to be flexible with topic tree design. Fan-in and fan-out scenarios need to be supported. There must be full support for wildcards and all the other features like retained messages, sessions, last will messages, return codes, error codes, user properties, and so on. If you want to know more about MQTT features, HiveMQ has a great series, MQTT Essentials and MQTT5 Essentials. You can watch that either on our YouTube channel, or they're also available as blog posts, and you can read up on everything that's available in the MQTT protocol. So I just want to spend a short moment looking at Azure IoT Hub. It is not MQTT 100% MQTT compliant. There is a couple of things that would not be possible here. There is no support for QoS2 messages. If a device sends a QoS2 message, it will get disconnected. There is no real support for retained messages. I'm having limitations on how to use topics. Generally, devices can only publish to device-specific topics and also subscribe to device-specific topics. There is no choice to pick a client ID or username. You have to use a TLS connection. That can be a problem for constrained devices that cannot handle the encryption. Just in general, there is no MQTT5 support. Now, it's not fair to single out Azure here. It's not much different for AWS. AWS IoT Core, for example, limits the topic tree levels to 7. The length, the size of the topic specified is limited to 256 bytes. There's a max message size of 128 kilobytes, no QoS2 support, and so on and so forth. And of course, also no MQTT5 support, which is too bad. Okay, so summary. I would strongly suggest to implement your IoT use cases and your IoT architecture with a message broker that's 100% MQTT compliant and supports all the optional features, especially for MQTT5. That's very important. That's how you get shared subscriptions, which might be absolutely necessary to have. You need an MQTT broker that's scalable, elastically scalable. That means it should be possible to add new brokers into the cluster as demand or load increases. It needs to be reliable and available. And the Azure Event Hub service is a great way to connect such a broker as HiveMQ is to the Azure ecosystem. And then you'll have best of both worlds. And that's really the end. I'll go to the resources. Jayashri, do you want to join us again? Gaurav? So as a resource, we'll suggest to look at the 2 blog posts, the documentation. Just take a look generally at the HiveMQ website for ideas and things going on. I hope you liked the talk, and yeah, let's jump into the Q&A. Actually, I'm not sure how to do this. Jayashri, help me.
So Gaurav, you can take over with the Q&A moderation. And
superb, thank you.
Yeah, and I will start a poll. I request you all to participate. It would be great to get feedback from you all. Over to you, Gaurav.
Thank you, Jayashri. So Matthias, there's a couple of questions around integration with the IoT Hub, the Azure IoT Hub. And the first question here is, Praveen is asking that you could send MQTT messages to Azure IoT Hub or to Event Hubs. So why do we need HiveMQ in the middle? And is the value we are adding limited to minimizing topics by routing through Kafka streaming? What's your opinion?
That's a really complex question. So first of all, I'd like to focus on hooking up directly to Azure IoT Hub. I think that that's going to limit you in a lot of ways. You have to do the device management. You'll be limited in other ways that the MQTT protocol is not fully implemented. And my point is that if you are having an IoT use case, consider using HiveMQ or another 100% compliant MQTT broker, and then hook up to Event Hubs, because that'll cut out the Azure IoT Hub restrictions, limitations, and you can directly use all the other great services that are available on Azure.
Right. And Matthias, related to that, I think what we are seeing with a lot of our clients who use Azure services, but then specific to IoT, one of the recent sort of trend we are seeing is companies who are trying to implement the Sparkplug specification. Because if you need Sparkplug specification, you need a broker or a technology underlying which fully supports MQTT 3.1.1 specification. And that's where IoT Hub kind of falls short, as Matthias has been explaining. So that's where, that's one example where, because the full specification is not implemented in IoT Hub, you would want to use a broker which lets you go beyond that. And just the other part of that question, Matthias, was, are you minimizing the topics by routing through Kafka streaming? What's your take on that? Are we minimizing topics?
I'm actually not quite sure what that means, because okay. Kafka streaming would sit, Kafka streaming is not sure that it would be available with Azure Event Hubs. So let's assume we have a Kafka message queue and we're using Kafka streaming. Kafka streaming hooks up to the Kafka queue and reads messages. We're not minimizing anything. Topics in terms of MQTT topics remain the same. The topic in Kafka, of course, we cannot use as many topics in Kafka as we use in MQTT, because in MQTT topics can be added as you wish into the millions. On Kafka, it's highly advisable to stay below 1,000 or something like that. So yes, you would probably need to gather together a lot of MQTT topics and direct them into one Kafka topic if you're dealing with millions of MQTT topics. I hope that kind of answers the question.
Sounds good, Matthias. And then we have another question from Matthias Krummel, which is around integration with Azure IoT Hub. I believe you answered it, but I must sort of also mention that you would typically do one or the other, and we are explaining. I think we have explained why that makes sense. The other question we have is around choice of topics for the namespace, and the question is, does Azure heavily constrain the choice of topics for the namespace? And they say that it has been noted as a potential problem for the data structure you need and the organization of user-defined data types and tags. What's your take?
So I'm assuming that this is not only the namespace, but it's also the actual queues, so the Event Hub queues, so to speak. Yes, I think that there are constraints on the naming of the namespaces. If that's a problem, then that's a problem. If You're also constrained in how many queues you can set up. It depends, again, on the pricing tier, but there will be an overall limit in the number of queues. Now, I'm not suggesting that it would be impossible to use Kafka here, right? So you could potentially use the Confluent Cloud. You could use a self-hosted Kafka instead of using Azure Event Hubs. But this talk was about hooking up to Azure Event Hubs and then having access to the rest of the environment. Makes sense. Thank you. And then there's another question around extracting information. So let me read this for you. It says, is there a way for the subscriber to extract the key, as in the original published topic, from the Azure Events Hub? I think it's more to do with the Azure Events Hub functionality, because as far as I know, the user properties, and there's several other fields in MQTT which allow us to pass on along, any information which is native to the topic or other user properties information that we can add. Any opinion on this, Matthias? So I might have an opinion. I actually haven't tried it out. So there is Kafka headers that on a Kafka instance can be used. So I can, for example, set the MQTT topic as a Kafka header. And there's a bunch of configurations that our Kafka extension offers. But I have actually not tried out to use that on Azure Event Hub. So I'm not going to say anything to that, because only stuff that I try out myself I can speak to. I just want to quickly pick up this question from Jan Herman. The benefit of running a two-node HiveMQ versus one. Jan, essentially, you get higher availability. The two nodes back each other. There's a replication factor on a HiveMQ cluster, so that if one node should get restarted, fails, maybe the underlying Kubernetes node crashed, your system keeps running. With a two-node cluster, you should then keep in mind that if you put more than 50% load on each one of the nodes, and then one node crashes, it gets a little tight here. So for production scenarios, we might go to like 3 nodes depending on the load, but yeah, that's one of the reasons. Laura? Go ahead, I'm done.
No, sorry about that. I was muted. So yeah, now I'm just looking through questions here, just given that we have a limited time left. I'm just trying to pick the ones closest to our topic of the day. So I think the next one we should pick is around DPS. Now this service, I'm not so sure about this service, which is the device provisioning service. So there's a couple of questions around it. One question is around how do you scale using the device provisioning service in HiveMQ? As in, people are trying to add many devices at scale automatically. What's the equivalent for that in our world? So it's a Microsoft service. Do you think it's something we want to tackle, Matthias, or?
No, I don't think so.
Okay, that's fair. Then we'll pass on this one, and happy to do a follow-up. So just please reach out to us offline, yes, and we can try and figure out a way to. Yeah. And the other question around, there's another question on Mosquito that somebody's asked. So quickly wanted to mention, as Matthias was pointing out, clustering is a crucial factor, and Mosquito has got its own advantages, but one of the things which it's limited around is the ability to cluster MQTT Broker. So please take that as one reason to look beyond Mosquito if you are looking to scale and make a reliable high uptime service. There's a question from Sania Khan, and their question is around they're working on streaming the sensor data to the cloud via the MQTT Broker. How can I make my sensor an MQTT client and stream the data to HiveMQ? So not specific to Azure here, but any quick comments on this?
That's a client device question. I'm not the best person to answer that, but the sensor needs to speak MQTT. So there's
Great,
client libraries available. So if you're, Sonia, if you're working on developing a client that actually can be installed into the sensor, then you would look for a client library that implements MQTT. We actually on our website have a resources page that lists available client libraries. I'm assuming you're not going to use Java on the sensor. It might be C, C++ or something like that. Take a look at that if that helps. Otherwise, if the sensor already has an MQTT client included, that would be the other way. Then there is translation software and devices that can take data from sensors that don't speak MQTT and then act as an MQTT client on their behalf. Yep,
great. Thank you, Matthias. The next one around Azure, not specific to Event Hubs, but let's see if there's some guidance we can provide them. They're asking, would you recommend Azure functions to digest, treat, and store the contents of the message received? And they say that they saw another Azure service in one of the earlier slides around this. Do you recommend Azure functions to digest, treat, and store the contents of the messages received?
So I'm assuming that we're talking about the messages from Azure Event Hubs and using Azure functions to pick them up from the message queue and then work further with them. Sure, that should be possible. Again, I haven't tried that out myself. I've actually had a lot of fun trying to get the analytics service to hook up to the to Event Hubs. That should be possible. I'm not quite finished with it yet, but yeah. So the functions, I would not hook the functions up necessarily directly to the broker, but via the queue. And that
sounds
good.
Sounds good. There's a question which I believe might be relevant also for the fact that we now have Event Hubs as the message queue. So I'm going to read only the part of the question which is relevant here. The question is from Eric, and the question is, how do you handle X.509 authentication when using a HiveMQ broker? So can we answer that in the context of Event Hubs here?
So I have no experience with Microsoft DPS, and X509 authentication, so mutual TLS, is supported by HiveMQ, but this probably also targets how to do device management, which I cannot answer here.
Sounds good. And I believe there's one quick comment from Praveen, which is about HiveMQ doing what they say is great service to the IoT community. They're saying they learned quite a lot through the educational videos, etc. So thank you, Praveen. Appreciate it, and appreciate your the gratitude you're saying you're expressing. Great, thank you for that. Let me see if we can squeeze this last one in, and it's again not specific to the topic, but let's see if we can help Mohammed here. So Mohammed's question is, what is the best SDK for connection and pub sub data to HiveMQ or another HiveMQ broker, especially in the .NET Core? Any opinion on that, Matthias?
Nope, I don't know the client libraries in the .NET Core. I can say that we have a great Java library, co-developed with BMW, but that, of course, doesn't help in the .NET environment. There is, however, I'm pretty sure that we have one client library listed on our resources page. So please check the HiveMQ website, take a look at that resource page, perhaps that helps.
Sounds good. That's pretty much the end of all the relevant questions we had here around the topic of the day. Jayashree, over to you.
Thank you, everyone. We hope you all enjoyed this session. So you will receive a recording and the slides in a follow-up email. We will also share the resource links which Matthias was pointing to. And if you have questions, you can also reach out to our community forum. Our support team will get back to you. So thank you, everyone, for joining us today. And we will see you next time.
Thank you. Bye-bye.
Bye-bye.